All set. Thank you very much, Dr. Mohanty, for inviting UNIDO to be part of this, and we're very welcome to, or pleased to contribute to this. We've heard a number of stories on the eco-towns, and that's a very interesting initiative, and I was also pleased, as Professor Fujita referred to be associated with that in the past. But my presentation would like to take it a little bit further, not just on the regional dimension of the eco-towns, but looking at a broader perspective of green industry for circular economy, and we already heard quite an extensive introduction on the circular economy before from Andrew and the keynote presentation. I would like to just put here UNIDO's main understanding of the circular economy. So we see here basically at the bottom the linear supply chain, material, supply, design, manufacturing, distribution, use, and then end of first life. And the issue is to add the circular economy practices. So we define it then as an industrial economy that routes materials and products back into several times, used several times, and more value with less waste. I think that is quite a straightforward interpretation, but we also recognize that there are many different interpretations. I would like to just mention here that if you look at the business community, which I talk much about, they are very much talking about this circular economy from the World Business Council for Sustainable Development perspective as 5 business models combined with 3 disruptive technologies. So the 5 business models are basically product lifetime extension, so using products for a longer period of time, sharing platforms, so multiple people using the same physical products, resource recovery, that's recycling recovery, product as a service, which was also referred to by the minister as the tires as a service, and the circular supplies, which is the renewables. And these business models unlock or are possible with transformative technologies, which are basically digitalization, physical technologies, advanced materials technologies, nanotechnologies, and biological enzymes and related technologies. So we see a combination of physical and business models coming to the fruition in the circular economy. Of course, we do this not for nothing. This has a profound triple bottom line benefit in terms of economic outcomes, particularly with production cost and improved competitiveness, new business activities, new technologies, enhanced consumer loyalty. And that's the environmental outcome, which we are particularly concerned about. We've probably seen the report last week from the International Resources Panel, which highlighted the role of resource efficiency for mitigating climate emissions. So we need to use materials more efficient and then reduce the emissions of pollutants and end-of-life waste. Then, of course, on the social side, we see new jobs, new incomes, improved health and working conditions, new partnerships that are happening. However, I think that we are still struggling, and I think that it's still the challenge with explaining the circular economy, that many people are considering the circular economy as an equivalent to a recycling economy, and that is perhaps not fully justified. So we have the 3 R's, which is very much at the core of this forum. Then we probably added there rethink, refuse, and repair as the 6 R's. We see now even people going to 12 or even more R's. But I think that the core the emphasis on the circular economy should be to close material cycles as comprehensively as possible. So basically, one might almost say that the circular economy is about even eliminating recycling. So we should have the sharing, reusing, redistribution, maintaining, and longer use. So it's not about recycling, but it's about keeping materials in perpetual cycles. So not one cycle, but not 2, not 3, but how can we go into perpetuality, either in natural systems or in physical systems and technical systems. So in that sense, we have been very much working on looking at how this can be translated into an industry agenda. And we have put some work there from the UN side to say that basically we're talking about 3 basic points, that we have to maximize the substitution of non-renewable material resources. So that's a resource shift, or one might say go renewables. then it's still very important to relentlessly practice efficiency, so to improve the efficiency of use of all resources. So if we talk about circles, the circle becomes easier to close if you have less materials in the circle. So that's the resource efficiency dimension. And then the third one is recycle or recover perpetually. So not just looking at one recycling, two recycles, but how can this work after 10 or 20 or 50 recycling cycles? So that is the value recovery, and that's resource circularity. And that is then enabled by shift to extended business models. And our experience is that these, working on this resource shift, resource efficiency, resource circularity is really an agenda for innovation, that we can get companies to start about thinking about new technologies. And I just want to highlight a few examples taken from our practice in India at the moment. So Go Renewables, the resource shift, is basically about resourcing man-made systems up to natural carrying capacity. So there's many opportunities, for example, for solar heating of industrial processes. Here you see a small example of a solar dehydrator for spices, fruits, vegetables, but this can also be done at an industrial scale up to about 400 degrees centigrade, which in India is more than 50% of the heat demand in industry, can be provided by these concentrating solar thermal products. Or we can also look at the biomimetics issue, so the copying natural systems into man-made products. We see Watson doing water purification without chemicals and energy. We can use biocatalysts for production of antibiotics, which we can do at room temperature, so no energy use, without solvents, so no waste, and higher efficiency, also less waste. And then the other one I would like to mention is Angli's Sumuk, which has essentially engineered a horizontal flame, which is the same way that charcoal burns, and it has the radiant heat transfer, which is much higher, and it saves up to 30% in kitchen appliances, but also in industrial boilers. Then the second point is then practice efficiency, and this is the work that UNIDO and UNEP and other agencies have promoted on resource efficient and cleaner production, which can then be addressed through different measures, housekeeping, input changes, better process control, technology changes, and so on. So the issue is still that we need to practice this resource efficiency and cleaner production with much more rigor and vigor to try to minimize the resource flows and then make it easier to close the material cycles. Just some examples of UNIDO's work. We did some work in the leather sector in Kanpur, which is famous for heavy leather in India. So we reduced the salinity and effluent load by 30% by hair-safe unhairing practices. We just add water measurement and control, and that saves up to 20% of water conservation. And we put up a few solar panels to actually save 10% of the heat with the solar air dryer of the leather. Then my third component is then the resourcing the man-made products in natural embedding the man-made products in natural ecosystems. So that's the resource circularity. And I think there we are seeing many products coming now that are closing the loop. So I just take an example from Arvind, which is a major denim producer. They are already using 70% of their water use is treated effluent from cities. 50% of the fuels is basically waste biomass. 20% of the denim is post-consumer recycled jeans. And then they do also salt recovery. Or we can go even further there. Pure waste cotton. So it's T-shirts made out of 100% post-consumer recycled cotton. We can also look at the wealth from waste. So can we look at organic waste, other waste streams to make value-added products? So Saatchi Eco Innovations makes a biodegradable sanitary napkin, which is made fully from waste banana fiber. So it gives an opportunity also to add additional income to banana farmers. Aspartica is a small company in Bangalore that actually extracts omega-3, which is fatty acids, which are very nutrachemical, so they're very useful from a health perspective, from silkworm pulpy. So after you extract the thread from the silkworms, you can extract this omega-3, and that can be added to feed for animals or even to food products. And then the last one is another example. So if we burn rice husk, we get a very high dispersed silica, and this silica we can recover and put it into tires, And if we put that in tires, it reduces the rolling resistance of tires, which of course means that there's less energy used during the lifetime of the vehicle that drives on these tires. So I think that we need to look at how can we get this started and what are the policy options, because ultimately we are here 3R as a policy forum. I think that it is important, in addition to listing all the instruments, to really be very clear that we need to discourage disposal, which is basically the landfill regulations and economic liability. We need to apply economic policy to reward circular with standardization of the recycled material content, with product requirements, with public procurement, and then we really need to also work on foster innovation through innovation and education policy. This is some of the work that was done jointly with the UN in India. So I will keep us in by 8 minutes by closing here and saying that basically the circular economy can mean very different things to different people, and that is maybe also fine, yet we need to make clear that it goes much beyond recycling, and it involves a circularity, which is about physical products and value chains with perpetual materials and resource flows. And it's also about economy, business models that create and retain value. It is designed in, as Andrew was also saying from the MacArthur Foundation, and provides basically a new lens to discover business product and process innovations. And those are then achievable. We have to industrialize those. Industrialize means making them standard, optimized efficiently, and do that in a quality way. And the industrialization of the resource rich, so using renewables, efficiency, and then the resource circularity. I will close here. This is just some of the initiatives that UNIDO is working on, where many of the additional examples are found. So back to you, Mr. Mohanty, to take the proceedings forward. Thank you very much.